Hello, everyone. So I'm here to speak how Sprockets works. But first, I want to know about you. How many of you know what Sprockets is? Okay, less than half of the crowd. So my name is Rafael Franca. You can find me at GitHub and Twitter as Rafael Franca. I'm member of the Rails Squad team. And I work for Shopify. It's an e-commerce platform that you can build your own e-commerce site. So in the Rails core team, one thing that I find is really interesting is that you can work whatever thing you want to work on. And there are a lot of people doing a lot of great work, like Errol Patterson working on performance improvements, and DHH always implementing new features. And my job is kind of the more less exciting of this. Like I'm the Rails maintainer. The person that releases every single version of the framework. Like every single release is made by me, except by the Rails 5.0.1 that's going to be someone else. And as a Rails maintainer, one thing that I really like to do is working out the projects that Rails has, not only the framework itself. So Rails is a spread of different projects. It is present in all the layers of your application, like in the process level with Spring, in the MVC stack with the Action View, Action Active Record, Action Pack, in the browser with the jQuery driver and turbolinks, and there is also the assets pipeline that is the thing responsible to build your assets. So I'm going to talk why do we need the assets pipeline, what are the chains responsible for it, how it's working in a Rails application, and how to extend it. So first, why do we need an access pipeline? So before the access pipeline in Rails was introduced, all the applications were different ways to build the client-side code. So one doubt that everyone had is where should I put my assets? So before Rails 3.1, we had no conventions about you organize your application, and people usually put assets inside the public folder, and that's totally fine. But when you have a huge client-side application inside your Rails application, you had no convention in organization at all inside that folder, and you end up with a lot of files that you even notice that they are used or not in your application. Like, so in that time, we also had to make some trade-offs because we could use a better code organization, but we lost performance doing that. And some things that we had to think about in that age was, should I make small self-contained files that is good for modularity and maintenance of the code, but doing that, it means that your browser had to do more requests. This means it's slower to load your page, so you have to do a trade-off between doing self-contained files or doing fewer assets requests. And for doing few assets requests, you had to put all the assets in the same file. That is possible to do, but is also really hard to maintain in reuse code. Another trade-off we had to do is, should I write legible code? I think that is not a trade-off today, like everyone is trying to write legible code. But in that age, we had sometimes to write in legible code, like variables with really short names and no documentation at all in assets, because we had to send fewer bytes to the client side. today we have a lot of good connection, internet connection, but in that time we did not have. So we had to do a trade-off between legible code or fewer bytes being transferred. And we also had some new technologies being created, like CoffeeScript and SAS, and most recently ECMAScript 6. So to solve all those problems and to make some of trade-offs possible, we introduced the Rails Apps pipeline. So how it works in a Rails application? So it's basically a set of conventions it does, and the first part of the assets pipeline is the convention itself. We now have a place to put assets, like you have a place to put all your style sheets, all your JavaScript, and all your images that are those directories. And you also have a place to put things that are libraries that you are writing to later open source it, or also assets that are not right for you, but for third party. And also, assets are now compiled on the fly. It means that you can focus on the things that are important for the code organization and maintenance. And Sprockets is going to do a lot of work for you for free, just to make possible like to do fewer requests in the browser and also have fewer bytes being transmitted. And another part of the Rails AS pipeline, it's also generate names with digesty in the end of file. It means that you now have an easy way to cache things forever. So you can actually set up your server to cache the assets for a huge amount of time. And every time the content changes itself, that digest in the end of the file changed. So now that we know how it works, we have to know what are the genes responsible for it. We have a set of genes that build the whole asset pipeline. Sprockets, what is the core of the asset pipeline? Sprockets Rails, SAS Rails, SHS, and Coffee Rails. The Sprocket genes compile and save assets. It's a collection of processors that where you can build pipelines. So I'm going to explain this further. The key components of Sprockets are processors, transformers, compressors, directives, and so on. I'm going to talk about them. So this is only for listing them. And the main component of Sprockets is called the processor. It is any callable object that accepts a hash as input and returns a hash of metadata. This is an example of a processor. A valid processor for Sprockets is just a lambda. It means that it's a callable object that accepts an input that in that case is an input with the data itself. So it's the assets that you are compiling, and returns another hash that is only returning the data transformed. This processor is really simple. It's easy to understand what it's doing. It's actually only removing all the semicolons from the file and return it back. So pretend that you have some JavaScript files with semicolons in the end. This processor is removing all the semicolons in the end of the line. So the input hash has some special meanings, like the data key is the assets being transformed. The environment is an environment object. And we have cache and source path, load path, and so on. And the return hash, it can be anything, but we have some special keys, like the data that is going to be used for the next processor in the chain, and some required stubs and links. Other keys that are important for the asset pipeline. So the only required key in that case is data, The another one are keys that is being used by default by Sprockets, but you can put anything you want there. So if you are building a new processor that is capturing all the images to do so, like images splitting, you can put a new key in that hash return. We have some built-in processors. The Babel processor is for compiling JavaScript next to JavaScript 5. CoffeeScript is to compile CoffeeScript to JavaScript, and the SAS compiles SAS to CSS files. Apart of the processors, we have the bundle processor. It's a special kind of processors that concatenate all the files instead of changing individual files. And you can register a processor like this. Like I'm saying that for all the JavaScript files, I'm using this class bundle as the bundle processor. The same thing with CSS files. This bundle processor takes a single file and prepends all the required URIs in the contents. Required is one of the keys that is returned in the hash. Another kind of process that we have is a transformer. It's a special kind of processor because you know the input type and the output type of the file. So let's say that we have a CoffeeScript file we want to compile it to JavaScript. We register that processor. So every single time that we see a CoffeeScript file, we generate a JavaScript file using this CoffeeScript processor. This is good because you can actually have more than one return for the same MIME type. So we can actually have CoffeeScript file being compiled to JavaScript and also to text just to, I don't know, return. We can have the same file being compiled to source maps and things like that. The CoffeeScript processor is easy to read. It's just a method self call that have the input and also returns another hash. And the important part of the code is there's two lines that is actually compiling the CoffeeScript file to JavaScript and putting in the return hash. We also have compressors that is a special kind of bundle processor. It's special because a part of you having a different way to register it, like it's uses the register processor or compressor. You also have a different way to use it. So you have two special keys, the JS compressor and CSS compressor. And this processor is used to compress JavaScript and CSS files, like remove space and comments and things like that. Anything that is not needed in the final file that's generated. Sprockets also has a concept called directives, and directives are special commands that declares bundles and the dependencies. And it looks like this. It just comments on top of the files, actually any part of the file. And what these comments does is telling Sprockets some informations about what it should do. In this case, it's requiring 3 files and 1 directory, saying that to build this application.js file, we have to include jQuery, jQuery UI, the users file, and also all the JavaScript files in this directory. And you can, the directives is just a different way to actually do this. This is what we use it to have in the Rails applications. It's saying to Sprockets that those 2 files, application and application CSS, are the bundles that is going to be generated. So no matter how many files you have in JavaScript, only 2 files are going to be generated that are these 2 two files. This is not is not true, because you think that it's only those two files, but actually Sprockets has a default value that looks like this, and it's really hard to understand what's going on there. But it's basically saying that any single file that's not JavaScript or CSS are going to be precompiled, and also the application, CSS application JS. We noticed that it's really hard to understand, so we changed the way we declare the files being compiled to a more declarative way. And this new way looks like this. So we are saying there that we want to compile all the images inside that folder, all the JavaScript inside the JavaScript folders, all the CSS files inside the style sheet folders, and also everything that my engine registered on the assets pipeline. And that in that case, the my engine is another manifest file that adds all the bootstrap images. It's one example of where you can use that kind of directive. Sprockets has a lot of directives. All of them are documented on the README. These are the list of all of the directives. So a part of directives, we also have the environment object. And this object is what has methods to retrieve and service assets, manipulate the load path, and register processors. It's basically the object that I was using in all my examples. Like, you can build the Sprockets environment really easy. There is no arguments to the constructor. And that find the assets method is actually telling Sprockets to compile that application JS file. And it's also on the environment object that I call all those methods that I showed before, like register compressor, register transformer, register processor, and so on. So the manifest file is the main endpoint. I'm going to show it later, but is the object that the end user usually deal with. You don't not have to know about processors, compressors, and things like that. If you are only using a Rails application, it's only important to you know it if you want to extend your assets pipeline to do something that Sprockets does not do yet. So, a part of the environment, we have also the manifest object, and this manifest object is only a cached version of the environment. So it logs all the contents of the assets of a directory and makes easier to find it later. So a manifest point assets to the fingerprinted version. And when you have a code like this in your view, like JavaScript include tag application, the HTML that is going to be generated looks like that one that's commented. And to build that, what Rails does is look to the manifest file to find the exactly mapping between application and the version that was generated. We also have the mapping in the another way around to get what is the name and when it was generated. So it's make it easier to us to expiring cache when you want to do. There is a lot more sets of components inside Sprockets that I'm not going to show here, like mime types, dependency resolvers, transformer suffix, and bundle metadata redundancies. They are more advanced features to people that want to extend Sprockets. And a part of Sprockets, we have the Sprockets Rails gens, and as all the Rails dash Rails gen does, it's only a gen to integrate Sprockets to Rails application. And these gens define some helpers, like those helpers that I showed before, like JavaScript include tag and style sheet link tag. It's also configured in Sprockets environment, so you don't have to know anything about the environment itself and put a good set of defaults. And it's also checked the precompile list. And what this is when you're trying to reference an asset that does not exist, DGen is going to show you an error like this. So we were trying to use a file called full.js, but we don't have full.js declared on the manifest file, so our error will explode. This is good because before we did not have this kind of check, and you only end up knowing that you had a typo in the file name when you were in production and your users were not seeing your JavaScript code. So apart from, we also have the SaaS Rails gens that integrates the SaaS processors with Rails applications. It's the same thing, like it's only a gen to glue together Rails and the SaaS. It's define some generators and create importers that know how to handle globs and RB. This is because SaaS by default do not know anything about those two features. For those do not know that the glob importing is like I want to import all the files inside the directory. That is only built in SaaS Rails. You cannot do that without SaaS Rails. And the RB handling is if you have a file that have ERB code inside it, the only way to produce CSS from that is using SaaS Rails too. And it's also configured the SaaS processors, adding a lot of good defaults, so you don't need to care how to configure SaaS and things like that. The next gen we have is the exact.js gen, and how the name is actually tell what it did. It's allow you to run JavaScript code inside Ruby. It's kind of a hack, like you are actually running JavaScript inside the Ruby VM, but it's worked really well. And it's actually using the JavaScript environment that you already have in your machine. If you are using a Mac OS system, you already have the Apple JavaScript core engine installed in the Mac OS, the same with Windows. So you can use enough those environments, like you can use the Node.js environment if you want to, and I really recommend to do that. So DGen is really good because it does this auto selection of the environments and also allow you to run JavaScript code. And DGen is made mostly for projects that we don't want to build again. Like we already have a CoffeeScript compiler made in JavaScript. We do not want to do the same compiling in Ruby again. So we actually execute the CoffeeScript compiling inside Ruby using DGen. What this code is doing is actually download the CoffeeScript compiler from the website and using that source code to execute a really small CoffeeScript code, like it's being generated on the last line. DGen is used by the CoffeeScript gen to compile CoffeeScript code to JavaScript code. Another thing that we have is the CoffeeScript gen, and DGen configures generators and defines a template handler. So in that case, it's a little bit different because this is not for the asset pipeline itself, it's more for the action pack. If you want to handle a CoffeeScript file, you only can do that if you have CoffeeScript Railgen. So I spoke about why we need an asset pipeline and also a little bit about what are the changes that made it possible, but how it actually works in development. So I'm going to simulate a request to the browser. So let's see that we have this directive in your views that is going to show to generate something like this HTML. And when your browser does a GET request to that URL, what is going to happen is the first thing that is going to hit your application is Sprockets Rails is going to use the pipeline called debug. And a pipeline is just a set of processes. And what this pipeline has is only a source map commenter processor. And this source map comment processor is going to generate the assets bundle and add the source map comment in the end. The source map comment in the end looks like this. It's just a regular JavaScript comment with a special declaration to a source map file. And to build the asset bundle itself, like concatenate all the assets, Sprockets is going to use the default pipeline. And the default pipeline is decorated like this. And it's calling the default processor for function inside the environment. What this function does is it looks for bundle processors registered for that MIME type. And if there is any bundle processor, it's only use that. So in the cases that we have a bundle processor for JavaScript, it's going to take that processor and execute it. So the bundle pipeline itself will compile all the files and mesh all of them together in one single file. And to compile every single individual file, Sprockets uses the self pipeline. The self pipeline looks really similar to the default pipeline, but uses a different function inside the environment. And what this function does is look for all the push processors for a MIME type. It later looks all the transformers for that same MIME type and later look for the preprocessor of that MIME type. And in the end, it's also add the file header processor. And this is a lot of code, and I made the image to make it easy to understand. Like, it's going to build a tree like this. So you have the file processor on the top of the tree, and let's say that you have CoffeeScript files, you have the CoffeeScript processor, and in the end you have the directive processor, and that arrows are the direction that the assets are coming in. Like, your file header is going to get the file inside the file system and pass for the next processor on the chain, and that processor is going to pass for the another processor in the chain until it returns back for the browser. So it's returned back for the bundle processor that merge all together, and the results sent to the browser. What are the key differences between what happens in development and what happens in production? The only difference we have is that in production, all of this happens in the precompile task, and only status assets is returned. Like, the difference is when you are in development, all of those steps work when you do a request to an asset. So it's a lot of work to be done in runtime, and in production we actually compile all of those assets in deploy time, so you do not need to do all of that when you are actually executing your code. So how to extend the sprockets? I have some ideas here how to extend the sprockets. It's actually real code that extracted from Shopify code base. Like, we have some ways to create new directives. So let's say that I want a special command to include NPM modules inside my application. So to create that, I define a new directive processor that inherited from the default directive processor of Sprockets. And we define a method called the process npm directive. And when you have a method called process underscore something underscore directive, that something in the middle of the two words is going to be used as the name of the directive. So it's actually only trying to find the file inside the node modules file folder actually, and adding that as dependency of your bundle. So after you write the npm processor, you register it. So you say that I want npm processors for all my JavaScript, so I just register it. And that is going to make possible to do things like this, like load dash from the npm node modules file. Another example that we have in the Shopify code base, we have a way to transform SVGs to PNGs automatically at deploy time. We need that because we have a lot of SVGs file, but some pages need to work on EA8, and EA8 do not know how to use SVGs, so we have to create PNGs for that case. And the way we do that, we have a special transformer from SVG to PNG, and this transformer is just an instance of the SVG transformer class. And the way we use that, we only say, like, we want to generate the full PNG from full SVG. We only use the link directive to tell that. The same thing, like, we can use the link tree to get all the PNG images from the image directory. And the code is really small. We are using the ARM magic chain to generate the PNG file, and it reads the input, and it sets the format to PNG, and later it just returns the PNG content. So Sprockets is used in many applications, but many users do not know it exists at all. And many users do not know how it works. And this talk is kind of a try of the Railscore team to explain better how the access pipeline works. And we had a problem because the original maintainer of the access pipeline left the Railscore and was not maintaining the Sprocket chain anymore. And no one else in the Railscore team had knowledge about how it works, so we had to research and understand it. And I was one of the persons that took the torch to maintain the Sprockets. And this talk is my try to tell everyone how Sprockets works, so we can have more people in the community know how to maintain Sprockets, if you need to. So it's important to you to understand your tools, to document your understanding, and to share with the community. That's it. Thank you. Do you have time for questions? Yes, it is. You only need a new processor. Like, you can actually use the bundle processor if you want, but maybe it's not going to work by default. So if you build a processor, a processor, and put it at the end of the stack only for get them all together, you can do that. Like when I showed the stack that we have, if you put your bundle processor after the directive processor, it's possible to do that. Yes. So you can put right after it and before the coffee processor. You can change the order if you want. Okay, so speaking about feature, we do that in Shopify by default. I consider it a hack. So right now the main problem is you have to start a new node process every time you actually compile a file. So in Shopify, we have a gen that loads the node process only once and reuses the same process. So that made a lot faster. But not only that, we are actually thinking on the Rails 5.1 to add support in Rails to different assets pipeline, like to have support to Webpack and Gulp, Grunt, whatever you want to use. And the idea about that is Sprockets, for me, is still the best option that we have right now in Rails, because Rails was built around that. But it lacks a lot of features that those other tools already have. And also, the JavaScript community is bigger on the Webpack part than Sprockets part. So we are trying to make it easier to get all the benefits you have in the JavaScript community inside the Ruby community itself. And also we have some, like, Sprockets is really heavy cached, so you have cache for everything. So one thing that right now is really slow, it's not actually compiling the assets, is really the cache. So we have some alternative implementations of the cache itself, because right now the default cache has a lot of problems because it's a recent used cache. And every time that you have to GC, I stop the word GC and it takes long. So we are trying to improve that.
Thank you.